central control of the circulation. So now, what controls it? What is the central control of the circulation? Well, that is the vasomotor areas. The vasomotor areas, well, how do they do this? Well, they are first of all located in the bilaterally they are located bilaterally in the medulla and the lower medulla oblongata and the very close to the lower third of pons. And then they have these parasympathetic, and they transmit parasympathetic and sympathetic nerves. As we already know, sympathetic it will transmit, and then it will go to the vagus of the parasympathetic will of course go to the heart. To the heart, and sympathetic it goes to almost every arterial in the whole body. Now the next topic I want to talk about is the vasomotor areas. The vasomotor areas, where we know that they're located bilaterally in the middle of the content and the lower thirds of the pons, but what is their functioning? So first of all, we need to know that they stimulate, and they can be divided into three areas. One is called the sensory area, second is the parasympathetic, and the third one is the sympathetic. So first of all, I want to talk about sympathetic. Sympathetic is going to go and it's going to send vasoconstrictors to the preganglion, it sends fibers to all levels of the spinal cord, and then it sends to the preganglion. And this causes then the preganglion neurons, preganglion vasoconstriction neurons of the sympathetic nervous system, and the intermediate levels of the gray level of the spinal cord. Now the next thing, we talked about vasoconstriction, let's talk about vasodilation. Well, they have neurons which they go and inhibit vasoconstrictors. Neuron bodies which go and inhibit vasoconstriction. And the last one is going to be, of course, sensory area. Sensory area is, of course, going to be the area where there's going to involve the glossopharyngeal nerve and the vagus nerve. So this is going to be that area where there's going to be it causes bilaterally in the tractus solaritus. Bilaterally in the tractus solaritus, the neurons they will receive from the glossopharyngeal vagus nerve, and they will control both vasoconstriction and vasodilation. And this is an example of a reflex. They perform reflex control and circulatory functions. And what is the next one? Afferents from the vasometric area. Well, it receives afferents from the aortic carotid body, the cardiopulmonary vessels. And what does this do? It also receives from the from the aortic and carotid chemoreceptors and the descending tracts from the cerebral cortex. They cause a vasoafferents from the lungs, afferent and pain impulses in the reticular formation. They converge on the vasomotor area and they cause vasodilation. So these were the main things about the central control of circulation, and that's the overall thing. Quick thing I want to touch upon is going to be the sympathetic and the parasympathetic. Parasympathetic, it goes on to innervate the heart, the glands, and these cause a release of acetylcholine from the parasympathetic nerves, and they cause vasodilation action. They cause the release of acetylcholine, and this causes vasodilation action. How does acetylcholine do this? Well, it converts when it activates the gluionized cyclase, it converts GDP to cyclase AMP, and this activates stuff such as nitric oxide, which causes vasodilation, and it also stimulates the release of bradykinin, which release of kallikrein from glandular tissue, which go on to make kinogen, and this makes kinogen makes bradykinin. Note that there is a mild but tonic discharge of sympathetic vasoconstriction and to most vascular beds, and there is no tonic discharge in the vasodilators. Now, the vasoconstrictor, there's been two ones. They can be cholinergic and non-adrenergic fibers. Cholinergic causes vasoconstriction, and adrenergic causes vasodilation. Non-adrenergic causes vasodilation, and cholinergic causes vasoconstriction. Cholinergic causes vasodilation, and the non-adrenergic causes vasodilation. So those are the main things I want to highlight. So if I were to recap, first of all, the central control of the circulation is going to be controlled by the vasomotor areas. These are located bilaterally on the medulla oblongata in the lower 1/3 of the pons. Addition to that, about they receive impulses they transmit impulses sympathetically and parasympathetically. Sympathetically to the heart, that's vague. Parasympathetically to the heart, and sympathetically to almost every artery venule in the entire body, through the spinal cord to almost every artery vein in the body. The vasometer can be divided into three parts: vasoconstrictor, vasodilator, and of course the sensory. Sensory, they receive from both they receive impulses from both glossopharyngeal vagus, and they cause both vasoconstriction, vasodilation. And this is a part of the reflex control of the circulatory functioning, because there's sensory. So remember sensory, remember reflexes from here. And what is vasoconstrictor? Well, that causes inhibition on the what do you call it, on the neurons. And then from here there is going to be not only inhibition, but there is going to be on the neurons, which cause vasoconstriction. And then the next functioning is that there is going to be a vasodilatory effect. So that will call vasodilatory effect. And then the last one thing I want to mention is vasoconstriction. So it sends sympathetic nerves to the spinal cord to almost every single arterial venule in the whole body, causing vasoconstriction. And one thing I forgot to mention was tractus solitarius. Tractus solitarius is the path. They are located bilaterally in the tractus solitarius. That's a part, I believe, in the brainstem. Correct me if I'm wrong. Afferents from the vasomotor area. They go towards the aortic carotid body in the cardiopulmonary area, and this causes carotid chemoreceptor, and this is going to be doing they also are involved with the cerebral cortex. So descending tracts to the cerebral cortex, aortic and carotid chemoreceptors, and the vagus afferents in the lungs, and the afferent impulses in the reticular formation converge at vasomotor areas, and they cause vasodilation. So this is the whole central control of the circulation. Please do like and subscribe if you like this type of content. I'll sure be making more. Thanks for watching.